Hello dear students, welcome to the part 3 video for the lesson Separation of Substances. So far we have seen about the types of mixtures, the properties of mixtures. We have also seen different methods to separate solids from solid mixtures. In this lesson we are going to learn about the separation of soluble and insoluble solids from liquid mixtures. This can be achieved using various methods which include evaporation, condensation, sedimentation, decantation and filtration. So we will learn about each of these methods and the basis or the principle of separation for each of these methods. We'll also be able to explain the techniques which are used to separate miscible and immiscible liquid mixtures using separating funnel and the technique of distillation. We'll go through a sample question where you will be able to apply correctly the most suitable separation method in a given situation. Now let's go to our lesson. Have you seen how salt is manufactured in the shores of Gujarat? Yes, salt is manufactured from seawater. As you might already be knowing, as you know, seawater is naturally salty and has a great amount of salt present in it. Salt can be separated from seawater by collecting seawater in shallow pits as seen, and then the water is allowed to evaporate from the sun's heat. So in the shallow pits, as the water evaporates, the salt that is left behind is gradually accumulated or it's collected by the salt farmers and it is heaped into the center like this, and when the water completely evaporates, the salt is then harvested or collected and then it is sent to factories for further refining processes. Salt is manufactured commercially for common use. Most of the salt that we consume comes from these salt fields of Gujarat. So what is the method of separation here? It is nothing but evaporation. The evaporation is a process of converting the liquid into gas or vapor state, as you already know. Here the seawater is allowed to naturally evaporate and there is no process of heating it or boiling it using energy, because that would be an energy consuming process. Why would we waste so much of energy when we can simply allow the water to evaporate, give it some time and it will evaporate because of the sun's heat, because of the wind and other factors. The shallow pits which we saw are called as evaporation ponds, and the salt water is allowed to stand in these ponds and the water evaporates, leaving behind the salts. The common salt which is got through this process is separated and it is sent to factories for further purification and packaging. Now what about the water? How can we separate the water from this? So water is not separated in the salt fields, but suppose you want to achieve the separation of the salt as well as the water, that is you don't want to lose the water that is lost as water vapor, but you want to collect it. What would you do? The simplest method of doing this is using the process of condensation. As you know, condensation is a process in which the vapor state of a substance is converted to its liquid state by simply decreasing the temperature, by reducing the temperature. So evaporation and condensation can take place together, can be made to take place together to achieve the separation of both the component of the mixture which was dissolved in it as well as the liquid part of the mixture. In this way, we can achieve the separation of a solid substance which has dissolved in a liquid mixture. When evaporation and condensation take place simultaneously, this process is called as distillation, for which you require a special apparatus and about which we will learn later on in this video. So evaporation and condensation are terms very commonly associated with the water cycle. So in the water cycle, as you know, the water evaporates in the vapor state from seas, and also because of the transpiration process from plants, a large amount of water vapor evaporates continuously and it reaches the upper layers of the atmosphere where it cools down. And when it cools down, it crystallizes. The water droplets crystallizes and forms ice particles around dust, and this is what leads to cloud formation. When the clouds become really heavy and they carry too much of these water particles and they become extremely heavy, they start the process of precipitation. In the process of precipitation, depending on the temperature, when the particles or the droplets of water begin to fall, depending on the temperature, precipitation can happen in the form of snow, in the form of hail, as well as in the form of rain. And when precipitation takes place, the water is then refiltered, it's collected in the rivers, in the lakes, in the sea, and the process keeps on happening cyclically and simultaneously. All these processes keep on happening in the water cycle that keeps our earth going. Now let's learn about the different methods which can be used to separate insoluble solids from liquid mixtures. So what if you have a mixture of sand or say soil and water? So we have learned how we can mix a handful of soil in some water, and then we can watch it separate into the different layers or different components that the soil is made up of, because the heavier components would settle down first, followed by the lighter components. So when we do this, we understand that the heavier particles of this mixture would gradually settle down at the bottom of the beaker and the clear water would separate at the top. This process is what is called as sedimentation. Sedimentation can be defined as the process through which dirt or any other heavier particles in a mixture settles at the bottom of the vessel when water is added to it. So when the heavier component settles after water is added, this is what is called as sedimentation. Once again, you can see that there are some dirt particles which are suspended in the water. You allow it to rest, you give it some time, and these particles would settle at the bottom. When that layer that settles at the bottom is what is called as a sediment. So now how can we separate the clear water from the sediment at the bottom? We can do this by a simple process which is called as decantation. Decantation is a process by which this clear water can very gradually be poured out using a glass rod into another beaker or container, and thereby we can achieve the separation of the sediment from the clear water. So decantation is a technique through which the insoluble solid substance can be separated from a liquid following the process of sedimentation. So remember that decantation is always a process that follows sedimentation. Remember that decantation cannot be used to separate a dissolved substance from its solution. Sedimentation cannot be used to separate a dissolved substance from its solution. That is, if you have a solution of sugar and water or a salt dissolved in water, the salt is never going to separate out of that solution and sediment no matter how long you allow it to sit. Similarly, the as long as you don't allow the evaporation process to happen, that is. And this is the process of decantation, where the liquid part, the clear liquid part can be gradually be poured out into a separate beaker following the process of sedimentation, and the undissolved solid appears as the sediment. Now, what if the water still has a few particles? Because when you decant, sometimes it can get disturbed and there might be a few particles of dirt still remaining in the decanted water. So how can you achieve the separation? You can simply use what is the process which is called as filtration. So filtration is the process by which the insoluble solids or the sand or dirt are separated from a solution. And this is done by making the solution pass through what is called as a filter. A filter paper is used to achieve the process of filtration, and we will see how to prepare the filter paper to achieve the process of filtration. Filter paper has really tiny pores or holes in it. So because the pores are very tiny, it allows only the liquid part to pass through it, and it holds behind any solid particles or dirt or sand or whatever solid was mixed in it. Insoluble solid that was mixed in it is separated. A word of caution once again, filtration is a process that is used to separate insoluble solids from liquid solid mixtures. If the solid is already dissolved in the solution, if it is a solution that is, it can never be separated by the process of filtration, but the liquid part has to be evaporated away using the process of evaporation to achieve the separation of the solid from the liquid. That is if it is a solution. So the fluid that passes through the filter paper, the fluid is what we collect will be called as the filtrate, and what remains behind in the filter paper is called as the residue. Take a look at how to prepare the filter paper. Filter papers come in a circular form. So to prepare the filter paper for the filtration process, you have to first fold it into half and then 1/4, and you have to separate the inner folds, the inner layers of the 1/4 fold to form a conical shape. Now this cone is then placed into a funnel, and then your mixture of insoluble solid and liquid is passed through the front filter paper through the funnel, and a beaker is placed at the bottom. The liquid part would then get collected as we filtrate in the beaker. It would be a very clear liquid because the filter paper will not allow any particles of the insoluble solid to pass through the pores, through their tiny pores. So what is collected in the filter paper is what is called as the residue. When we prepare tea, filtration is the kind of process that we use. We do not require filter paper in that case because the particles or the tea leaves are large enough to be separated using a strainer, which is basically a mesh or a kind of a sieve. The filtration process is also commonly used for in water purification systems that we use at home. Let's take a quick look at the three processes which we just learned: sedimentation, decantation, and filtration. Sedimentation, decantation, and filtration are used to achieve the proper separation of insoluble solids from solid liquid mixture. In the process of sedimentation, the mixture is allowed to stand so that the heavier particles of the mixture, the insoluble solid, settles at the bottom to form the sediment. So you can obtain clear water from muddy water. Then, by the process of decantation, the clear water can be gently poured out into another beaker without disturbing the sediment. Now, the clear water can be further purified to make sure that it is clear, or maybe at the very beginning itself, if there is very little mud in it, then you can directly use the filtration process using a filter paper and a funnel system. The filter paper has very tiny pores which will allow only the clear liquid or water to pass through it. The clear water that is collected is called as the filtrate. What the unwanted component which is left behind in the filter paper is what is called as a residue. A quick recap of what we just learned: the separation of solid in liquid mixtures. If the solid is dissolved in the liquid, you use the method of evaporation and condensation to collect the liquid part also. If the solid is insoluble in the liquid mixture, we can use the processes of sedimentation, decantation, and filtration. Now let's learn about the separation of miscible liquids. Do you remember what miscible liquids are? Yes. Miscible liquids are those liquids which can mix completely with each other. That is, they can form what we call as a homogeneous mixture. For example, if you mix, say, water with milk, or if you mix soy sauce with water, we get a miscible liquid mixture. Distillation is the most commonly used method to separate miscible liquids. We have already seen that distillation is a process in which evaporation and condensation happens simultaneously. Now, for this to happen at larger scales, a special kind of equipment is required, and this is called as the distillation apparatus. So, what is the basis of distillation? Distillation makes use of the difference in the boiling points of the components of a mixture. So when the liquid components of a liquid and liquid miscible mixture is having different boiling points, we actually use that to achieve the separation using the distillation apparatus. Let's take a look at the distillation apparatus. It has a round bottom flask with two mouths. The larger mouth is actually sealed or clamped using a rubber cork onto which a thermometer is fixed. It has an outlet, a small pipe also at the top, which is further connected. It has an outlet or a long pipe at the top, which is connected to an outlet. Around this outlet, there is what is called as a Liebig's condenser. So Liebig's condenser is basically a larger pipe having an inlet and outlet to allow water to pass around the pipe that is coming from the round bottom flask. So this basically allows this pipe to cool down, and the condensation process thus happens. So where does the evaporation process happens? The evaporation process happens when you heat the round bottom flask. So heat is applied over here below the round bottom flask by placing it on a Bunsen burner or on a flame. Here we are trying to achieve the separation of a mixture of acetone and water. So as you all know, the boiling point of water is around 100 degrees Celsius, and the boiling point of acetone comes much below 100 degrees Celsius. In fact, the boiling point of acetone is only around 56 degrees Celsius. So when you begin heating the mixture of acetone and water, which is completely mixed together, they are miscible liquids. Which form homogeneous mixture. So when you begin heating, what happens is that as soon as the temperature reaches 56 degrees Celsius on the thermometer, the acetone vapors start rising. Water will not have vaporized yet because the boiling point of water has not reached. So remember that the properties of the components of the mixture are retained. So the acetone will have its own boiling point and start vaporizing, that is changing to the vapor state at 56 degrees Celsius. The acetone vapors will then go through this long pipe, the long outlet, and as the vapors move through this pipe, the vapors are cooled down because of the water that is passing through the Liebig's condenser. The Liebig's condenser will allow the vapors to cool down, and the vapors will condense to form the liquid form of acetone inside the tube itself. And then the liquid acetone will be collected in a flask or a beaker which is placed at the other end of the apparatus. If we allow the mixture to further boil, then what happens is that as soon as it reaches 100 degrees Celsius, the water will also start boiling and vaporizing. But here, when you have separated the acetone, all the acetone from the water, then the separation has already been achieved. Another thing to note is that when the temperature on thermometer reads 56 degrees Celsius, it means that the acetone has started vaporizing, and the temperature will remain constant at 56 until and unless all the acetone in the mixture has completely vaporized. So when the temperature starts increasing, that means that all the acetone has vaporized and the process can be stopped there. So distillation is a method which is used when the components of the mixture have different boiling points. Now distillation is used on a large scale for the separation of products such as petrol, diesel, lubricating oil, paraffin wax, naphthalene, kerosene, asphalt from crude oil in oil refineries. So crude oil is a natural resource which is taken or drilled out from deep inside the earth, and the crude oil that is got from here is then sent to oil refineries. What is done in oil refineries is basically a distillation process. Each of these components of crude oil has a different boiling point. So each of these will separate at a different temperature. And this is the basis of the working of these oil refineries. And so we get so many different products from crude oil, which are very important for different industries. Now, how can we separate an immiscible liquid from another one? So, as you know, oil and water are immiscible, and they will separate into different layers on standing. Separation of immiscible liquids can be done using a process which is similar to decantation. Decantation can be used to separate immiscible liquids, but it is not like the perfect method, or it cannot be you cannot achieve a perfect separation using the decantation process unless and until you use a particular apparatus which is called as a separating funnel. So a separating funnel is basically a funnel which has a stopcock which is fitted at its mouth. The stopcock can control uh, the stopcock can control the flow of liquid from inside the funnel through the outlet. So you close the stopcock and then you pour your mixture of oil and water into the separating funnel. You allow it to stand for some time. It will separate into two different layers. Once the immiscible liquids have separated into the different layers, you gradually open the stopcock and allow the water to flow down. As soon as the water has completely separated and only the oil is remaining in the funnel, you close the stopcock, and thus you have achieved the separation of water from oil. And two immiscible liquids can thus be separated using a separating funnel very effectively. So it is a kind of process of decantation, but it requires the use of a separating funnel to be done properly. So kids, we have learned about different separation techniques which can be used for separation of solids from liquids and liquids in liquids. Liquids in liquids, remember that liquid in liquid can either be miscible or immiscible. When we have miscible liquids, we achieve separation by making use of the difference in their boiling points, and we need to use a special apparatus for it, which is called as the distillation apparatus. To achieve the separation of immiscible liquids, which separate into different layers, we use a separating funnel which can control the flow of the liquid from the funnel to the outlet. Now, dear children, remember that whenever we try to achieve the separation of a mixture, we have to closely examine the properties of the components of the mixture which need to be separated. Very often, more than one method might be needed to achieve the separation. For example, how can we separate sand and salt mixture? To separate a mixture of sand and salt, we can make use of the property of salt. That is, the salt is soluble in water, whereas sand is not soluble in water. So the first step to achieve the separation would be to pour water into the mixture of sand and salt and give it a good mix. You can expect all the salt to completely dissolve in the water. And what would happen to the sand? The sand would simply sediment at the bottom of the beaker. The next process will help to separate the sedimented sand from the salt solution. And this would be nothing other than the decantation along with filtration process. So when the salt water is poured into another beaker and that too through a filtered paper, you are achieving both decantation, but it is done through the filtration process. So now we have separated the salt water from the sediment completely. Now how can we separate the water, or how can we separate the salt from the water? Because now the salt is dissolved in the water, we can simply heat the water and the water will evaporate, leaving behind the salt. If we want to achieve the separation of the water also, we can use a simple condensation method, that is using a plate or a pan onto which ice is placed to cool down the surface. When the vapors hit the cool surface of this plate, the vapors of water will condense, and by simply tilting the plate, you can actually collect them in a separate beaker. So in this way, you can actually achieve the separation of the salt, sand, and here you are even able to separate the water from the salt solution. In this way, dear children, many methods can be used parallelly to achieve the separation, and very often more than one method could correctly be used or to effectively achieve the separation too. So it all depends on how you actually analyze the properties, the difference in the properties of the components of the mixture before you decide on a proper separation technique. Hope you will go through the different kind of mixtures which are given in your textbook, and you try to find out which separation technique would be more suitable in each case. I'll see you again in the next video. Until then, goodbye and keep learning.